let's see. I will go ahead and start new analysis and call it soccer world. So question number 11 I have started. I will go ahead and start the Soccer World Cup 98 analysis 1, and this is where I will have the opportunity okay, let's see. I'll choose one network. I'll choose the the one, of course, I was assigned, and click here. Okay, good, and then continue. The measures I was asked to add are the first one. Question number 1 is about articulation point. I need to tell whether I will also need on question number 7, I'll need the average neighbor degree. I need to tell whether the graph is biconnected. If the graph is biconnected, if the graph is bipartite, and if the graph is Eulerian. I will also need to find the bridge edges. And need to find clicks. So what is a click? Determine the number of clicks of size 3 and larger. Find click number. No. Find the largest click containing a given node. Find all maximum clicks. Find the maximum click. No, I think the one I'm looking for is find click number. I think I'm on parameters. I am being asked to find the number of clicks of size 3 and larger. So this can't be the maximum click size. Yes. I do not know what the maximum clicks are. But I can sure count them. Clicks of size 3 and larger. Not sure about that. So as far as clicks are concerned, alright, I'll count the clicks and I'll find click number. So that's what I will do. Hang on, that's the same thing. Count clicks and finding click number. I don't know, I'll try both. Find clicker number. Alright. Then another measure is to find the eccentricity for a node and how that's related to a diameter. Then I need to find the largest of the eccentricity. Alright. There we go, eccentricity. How about diameter? I know that the largest diameter. Yeah, I have both. For all the centrality metrics, I mean betweenness 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. No, well, since I have an indirect, non-directed graph, so I don't need these two, but I'll probably, I guess I'll use this 1, 2, 3, 4. What they say. Alright, so all these are centrality measures. So I think that's what all the centrality metrics that CINET can find out for you. Find out the top 5 vertices that have the highest centrality score for each of these metrics. These are exactly almost the same set of vertices for all the metrics, or are they different? Explain your observations. So find out the largest value of the average neighbor node degree. So I already selected that. Average neighbor node degree. Yes. And then the maximum click of enter and the maximum click containing node 1, are they the same or different? So click again, find the largest click containing node 1, and then find the maximum click. So that's question 9. And then I need to determine the authority and hub scores of all the So authority, all right, as well as the page rank. So I need hub, authority, and page rank for the network. Maximum click containing node 1. All right, I just found that I might have misunderstood question 11, but we'll see about that. All right, so I have this whole list of things I am supposed to do. You know what? I don't know if I should take a screenshot of this, but I can do that. And I will let's say these are the measures I'm taking. Anyways, great. Now that we have all this, I will say go ahead and analyze. What? It's already completed. That was fast. So the computer runs this and pretty much brings me the report of all this. And I guess I do view report, and we will start with articulation. And the output file says I have vertices 14, vertices 14, 28, and 10. 14, 28, and 10. Average list of the nodes with the average neighbor degrees, and this is a long list. So that's for the average neighboring degree. Then I can find out more. So basically, what about that? Okay, whether the graph is back connected, check if graph is. So the graph is not back connected. Is the graph bipartite? Not bipartite. is the graph Eulerian. Not Eulerian. As far as finding out what these mean, screen, what is the bridge edge list them if your network has any? Does my yes number of bridge edges. So I have 3 bridge edges that span from the which connect node 1419. Number of bridge edges, so I have 3 of them: 14, 19, 23, 28, 10, 17. Determine the number of clicks of size 3 and larger. Count clicks. So right now I have three and larger. As far as clicks of size 3 and larger, I have click size 3, number of clicks of that size. I have 117 clicks of size 3. Notice that this graph has only 35 nodes. I can show you later how to see that, but for now I don't know how to find the other ones. Clicks, degree, centrality, find click number. So what are the measures of eccentricity that we have? Duh. All right. We have here the list of node ID and their eccentricity. I'll go ahead and download. So you have like a little log file that says what the program did or outputted during the processing of this. So the eccentricity is 3, 4, and 5 here, 5 being the highest number. 5. and node 19, node 23, and the node, just curious, trying to see which are the nodes with the eccentricity of 5. All right. What else? What else? Number 6. All the centrality metrics that CINET can find out for you. Find out the top 5 vertices that have the highest centrality score for each of these. So we are listed about 4 centrality. So we'll start with betweenness centrality. Yeah, we have 35 nodes and 118 edges. And as far as centrality is concerned, as far as betweenness centrality is concerned, I guess I'll have to graph this to really see what's going on here. Or yeah, I can just copy. I'll put them. I'll download them, then put them in Excel, sort them out, pick the top 5 for that measure, and then I'll do. Here we go, betweenness, and then I'll do the same for closeness centrality. Oh, only 2 here. So that maybe I can compare at least. As far as closeness centrality is concerned, apparently nodes 24 and 10 have 0 closeness centrality. I don't know what they do not report anything about the other ones. Download. Let's see how 24 and 10 behaved for betweenness centrality. So 10 had a 97 betweenness centrality. And node 24 at 23. Anyway, so degree centrality. Here we go. For this one also. It's a lot of measures. I will have to sort them out in Excel to find out degree centrality, to find out, their order of importance. So if you know how to sort in Excel, that's how I'll do it. Eigenvector centrality. and these are the values. I will also have to sort them out in Excel. So, and there goes, and that's it for the 4 measures, and that's so question number 7 wants us to find the largest value for the average neighbor node degree. Average neighbor. I see 11, 13, 13, I see 19, so 19 is the highest I see here. So node number 17, average neighbor node degree is 19.0. Is this node among the top 5 vertices that are found for any of the centrality metrics above? Possibly, but for now I will so I'll wait until I can compare them. The probability or frequency degree distribution of the vertices. Probability, did I don't think find maximum. Oh, one of the questions talked about diameter of the graph is 5. What is the previous word? Now, one of the questions, number 5, large node eccentricity values 5, and that corresponds to the diameter. So that's how they're related. In fact, the largest eccentricity value is the diameter. It's like how far out can anything be, you know, that's basically the diameter. No, hang on. That sounds like the radius if you are looking at the center. That's a good observation, I guess. But here we go. The large node eccentricity value is 5, and the diameter of the graph is 5. I wonder if they should not call that the radius. Oh, maybe the eccentricity value is compared even to the ones on the edges on the opposite side, not just from the center. Food for thought. So probability degree distribution. I will need to do this in Excel. Next, maximum click of my entire network. Largest click, maximum click, and set of nodes in the maximum click. Haha. Formatting problem, or the U might mean something else that I do not know, but that's the maximum click of enter and the maximum click content. Okay, the maximum click of my entire network. Set of nodes in the maximum click is 10, 12, 18, 35, 24, and 25. 24 and 10 were also 24 and 10 were also special for some reason. Yes, they were also in closeness centrality, they had the highest score. I guess it's part of it, they're part of the click, therefore they will be very close. Set of nodes in the maximum click, and then the maximum click containing the node so the largest click containing node 1. Are they different or the same? They are different clicks, and they are different from the maximum click. So 1, 18, 9, 12, and 1, 18, and 7. I guess this is not about communities because we have repetition of certain nodes into different clicks. So determine the authority and hub scores as well as the page rank scores of the vertices in my network. Are the vertices with the top 5 authority scores or hub scores same as the vertices with the top 5 page rank scores? So authority and hub. Hub score and authority score. I will have to sort this in Excel. So for now, I will go ahead and download hub authority. And then page rank. And this one also will need Excel sorting. And there I will explain my observation. And then I need to visualize my network by varying the node size on the basis of each degree and betweenness centrality. Now I am asked to try the Yifen-Hu and Yifen-Hu plus Forza Trust layout. So I've used, did I do degree earlier? Degree centrality? I think I did. Let me just re-download because I'm gonna need that. Oh, I did already. Never mind. All right. So that's it for these measures. I will go ahead and and add one more measure, that is the probability of frequency degree. And then on this here, I'll run some new analysis on the soccer network again. And I'll name my analysis Soccer World Cup analysis just for probability degree distribution. Apparently CINET does not have whatever we call probability. Or frequency. Maybe I'm not understanding this. So what is this? Probability degree statistics. Suppose that's the degree statistics. All right. All right, analyze. In progress. The statistics are taking a little longer. But they are done now. Well, it's one thing to get these measures, it's another to understand them. I know this is the number of edges or sorry, this is the number of vertices or nodes, and this is the number of edges. The minimum degree is 1, maximum degree is 19, the average degree is 6.1. I need to ask the teacher about this, but question number 18, no, number 8. The results for degree. So vertices, I mean edges, I have 35 of them. Sorry, number of vertices. Edges, I mean I know that already, 118. Minimum degree, (11). Maximum degree, 19. Average degree, 6.74286. So here we go. And by the way, for credit purposes, this is where this is all happening. They should have Jackson State in this list. I mean, I guess we are under the National Science Foundation. Oh, I also need to visualize my network. And soccer. So I'll add another visualization in this one. Let's say so the size this time will represent the degree. Size for degree. Okay, betweenness will be in color. I'll just increase that. So visualization request submitted. If I come back here, that one is still running. So this is the soccer network. Basically what this network is when two countries, I mean in this in the way soccer works is people who play national teams can be kind of rented out to other countries, and each node represents a country in this picture, and there is an edge if between two nodes if someone from that country has been kind of rented out to the other country. So for example, I don't see a connection between this edge and say this one, which basically means that nobody from that country, say this one, has been sold to that one or this one. All right. Oh, just one more visualization, and I guess I'll be. Oh, this one is still running. So in the new one, the degree will be by size, and in this one, it's the betweenness. So you see, betweenness centrality. Betweenness centrality is greater for node 18. That's what the size represents, and sure enough, you can see it like being pretty much in between a good bunch of them. I guess this being too far over there made this have greater betweenness, and then oh, I also need to do a couple more things. So these here, by their size, they represent betweenness centrality. Otherwise, node 17, because it has yeah, there it is. It has the average neighbor node degree for, it has the largest value for the of 19 for the average neighbor node degree for any node in the network. Is this node among the top 5 that different from? So node number 17 has the average neighbor node degree, the highest. I have no idea why, considering where it really is or not. Maybe. Anyways, maybe I can Google a little bit like the average neighbor node degree or network analysis. Yes, average neighbor node. What does this mean? I hope I downloaded this. Yes, I did. All right. Great. Now I will take a screenshot of this. We have like these four here: 10, 18, 12, and 13. 10, 18, 12, and 13. Yeah, it's kind of difficult to see clicks when there are so many lines in here, but here we go. So I will take a screenshot of this as well. And say maybe this one too. Actually, maybe this is the one I should include in the report. And then report this one too. No, wrong information on it. There we go. Then I need to add some more visualizations. In Force Atlas 2, without, let's see what it does without any of the parameters. I'm curious. And then another visualization in vis through first turn on rain gold. Without any of these, just generate. And finally, Yihanfu itself. Yihanfu. All these three have one thing in common. They are all force force related or force just a second. They are all yeah, they are all force directed force-directed layout. And then Yi Fan Hu, which is it assigns attractive and repulsive forces between vertices and finds the optimal layout by minimizing the energy of the system. So here we have a graph in Yi Fan Hu. In Yi Fan Hu. And then we can have it in Freshman Randgold. Ooh. And then we can have it in Forza Class 2. I want this to appear. There we go. Interesting, interesting. So this is the layout in Forza Class 2.
What's good, man?
What up?
You look distressed.
A little bit. A little bit. doing a little project and gotta visualize networks and stuff and explain what's going on. Here we go. Looks like it's cool little things, but like I'm representing the same network in three different, following three different algorithms.
Right.
Like this one, that one, and that one. Looking at the same network, and they all represented the same network differently. This guy, his algorithm renders it this way. This other one renders it this way for another one. And I have actually a couple more visualizations of the same network. This is the most beautiful one because I included colors. And this one represents other things. Anyways, so it's kind of low. Network science is the class,
Okay.
and it's fun. Dr. Meg teaches it.
Is it what's your major?
Computer engineering. But it's a computer science
Right.
class, but I'm taking it as an elective.
Okay.
Yes, sir.
I might have to hit that up.
Check it out. Yeah.
Where you going, Charlie? I'm back here.
All right. Reach out telephone for explain what. All right, and I think that should be it for the video. And you just hit